Imagine plugging your house into the wall one day and never paying another electricity bill. Power flows endlessly, cleanly, without interruption. No gas, no oil, no wind farms. Just pure energy, born from the same process that powers the sun. It's called nuclear fusion. And after decades of setbacks and false starts, the breakthrough has finally happened. For the first time in human history, fusion energy has produced more power than it consumed. This isn't a theory anymore. It's real. Fusion is the process where two light atomic nuclei, like hydrogen, combine into a heavier one, typically helium. When this happens, a small portion of their mass is converted directly into energy, according to Einstein's equation, E equals mc2. That's the same process happening in the core of every star in the universe. And if we can do that here on Earth, we'll have access to an energy source that's virtually unlimited, produces no carbon emissions, and leaves behind no long-term radioactive waste. But there's a reason it's taken this long. Fusion needs insane conditions to happen. In stars, the massive gravity provides the pressure needed to force atoms together. On Earth, we don't have that kind of pressure, so we need to compensate with heat, lots of it. We're talking temperatures over 100 million degrees Celsius. That's hotter than the core of the sun. At that temperature, matter becomes plasma, a state where electrons are stripped from atoms, leaving behind a chaotic soup of charged particles. Now here's the problem. You can't just put that kind of heat inside a metal box. It would vaporize instantly, so the plasma has to be held in place without touching anything. That's where magnetic fields come in. In the most advanced fusion devices, called tokamaks, powerful magnets create a magnetic field that suspends the plasma in a donut-shaped vacuum chamber. Nothing touches anything. Inside, it's hotter than the sun. Around it, the magnets are kept just above absolute zero, minus 452 degrees Fahrenheit. It's like holding hell inside a snow globe. And somehow it works. When the plasma is stable and hot enough, the fusion reaction begins. Hydrogen atoms collide and fuse into helium, releasing a burst of energy. Neutrons carry that energy into the reactor walls, where it's used to heat water, create steam, spin a turbine, and generate electricity, just like any other power plant. The difference is there's no combustion, no pollution, no carbon, and no meltdown risk. If something goes wrong, the plasma simply fizzles out. There's no chain reaction, no explosion, just silence. That's the theory. But in December 2022, it became reality. At the Lawrence Livermore National Laboratory in California, scientists fired 192 lasers at a tiny fuel pellet made of hydrogen isotopes. In a fraction of a second, it collapsed, ignited, and released more energy than the lasers put in. Just for a moment, but it was enough. For the first time, fusion worked. Meanwhile, in France, the world's biggest fusion project is under construction. It's called ITER, a collaboration between 35 nations, including the US, China, India, and the EU. ITER is building a tokamak reactor designed to produce 10 times more energy than it consumes. It's not just a proof of concept. It's a full-scale test of continuous, self-sustaining fusion energy. The first plasma is expected around 2035, and if it works, the path to commercial fusion reactors opens wide. Fusion fuel is everywhere. One of the primary fuels, deuterium, is found in seawater. Just 1 liter of ocean contains enough deuterium to power a house for several days. And since there's no need to dig, drill, or transport anything, there's no geopolitical vulnerability, no pipelines to defend, no dependence on unstable regimes. Every country could become energy independent. Critics say fusion is too expensive, too complex, too slow. And they're not wrong. It's taken decades and billions of dollars to get this far. But here's the thing, progress is no longer theoretical. The first working experiments exist. The hardest part, proof it can be done, is behind us. Everything that comes next is just engineering. And the same thing was said about solar panels, about electric cars, about reusable rockets, until suddenly they weren't the future. They were everywhere. Maybe we won't have fusion tomorrow, or next year, but we will have it, because now we know it's not impossible. It's just inevitable. This is almost fiction, but not for long.